Thank you all for taking the time to join us today in this session's office hours. My name is Ethan Schmargot. I'm a product manager for the Oracle Database Security team. And today I'm joined with my colleague, Peter Wall, who is the product manager for both Oracle Key Vault and Oracle TDE, or Transparent Data Encryption. And today he's going to be talking about some exciting new features in Oracle Key Vault 21.10. So keep in tune and keep in touch with that as soon as I finish up these brief announcements here. So again, want to remind y'all that we have a GitHub page where we share the links and examples we talk about during the session. I will share that GitHub link and all of the other relevant information once Peter gets started. In that GitHub repository, you could find almost 2 years worth of notes available just by going to that repository. GitHub.com/or dbsec/asktomdbsecurity. Again, I will note all of these and send all of these URLs in the chat once Peter gets started. And then, yeah, every month we remind you to stay on top of your patches, right? Release updates come out in January, will come out again in April. So please stay on top of your patching, whether it's the database, the application, the operating system. The easiest way for attackers to compromise your environment is to take advantage of those known vulnerabilities that should be patched, right? So Oracle publishes patch updates, security alerts, and different bulletins at oracle.com/security alerts. If you're using real application clusters, rack, please look at fleet patching and provisioning to improve your grid and database patching performance. As always, Mike Dietrich is the expert when it comes to patching and upgrading, so you can also feel free to check out his blog at mikedietrich.com for some more information regarding patching, some more of that cool stuff. Here's one of the live labs that Peter's going to be talking a little bit more about today. I'm sure he will also provide the URLs and the QR codes for this as well. But this is one of the labs that Peter's going to be talking more about today. It is a brand new lab. I know Peter has worked very, very hard on coming out with it, and it explores a lot of the cool new features around Oracle Key Vault, specifically around SSH key management. And I know, like I said, Peter will talk a little bit more about this during his time today. But again, Peter's worked very hard on coming out with this lab, and it's a really, really good one. So here's the QR code for that. Again, I'm sure Peter will provide you all with the links and another QR code in a little bit as well for it, but the first introduction to it. And then, yeah, we have more than just that Key Vault lab. I think Oracle Database Security has over 30 plus live labs dedicated to database security that y'all can go and even spin up on Oracle's dime, right? Go reserve an environment, spin it up, play around with our technologies, follow a lab. It's a really, really good and easy way to get going with our technologies and learn more about them as well. So with that being said, I will pass it off to Peter to talk a little bit more about Oracle Key Vault 21.10. All right, Peter.
Okay, good. So this is part two of a longer presentation. The first part is TDE. I will skip over that and go into OKV directly. So now that you have encrypted your database, you can still, because TDE is transparent, you can still select from your table, but if you try a side channel attack, okay, so that is not, here we go. So now it's encrypted, and the next question is, of course, where are my encryption keys? And in my time as the product manager for TDE or a sales consultant who sold TDE, I've seen everything, believe me. So there are deleted wallets. Uh, People forget the wallet password. This is all very bad. And there was one case where a company wanted to upgrade hardware and software. So they wanted to relocate an older database version to a newer hardware. And they noticed that the DBA who set up TDE left 15 years ago. So they didn't even remember their name. So they didn't even know who to ask for the wallet password. So those are things that really happened. And I also had one customer who called me, yes, I have a wallet, but the keys are gone. So there's basically everything that can happen. And the worst case is basically if you have somebody in your network who says, well, I got them, but you have to pay me to get them back. So this is not good. And for this, I believe this is where the PCI requirement comes from. That doesn't allow you to store key encryption keys next to the data encryption keys. So basically, your wallet has to go and put someplace else. So where to put it? Well, into Key Vault. And this is a little bit of a history. We introduced transparent data encryption almost 20 years ago. And at that time, our customers encrypted 5 databases, and in those databases, only the credit card numbers. And for key management, we needed to rely on third-party HSM providers. Those HSMs could easily handle those few databases, no problem. But if you fast forward to today, then I have a handful of customers where everything needs to be encrypted. So even if somebody spins up a database to try something out without any data in it, it needs to be encrypted regardless. So we needed to come up with a key management solution that um, satisfies the customer challenges. So some of them asks, how can we do key rotations? Um, we we need a key management solution that never, under any circumstances, loses keys, right? That would be not good. And of course, we know that our customers are putting their databases onto highly consolidated environments like Exadata. Of course, it's an Oracle solution. It needs to play with everything. So if our customers are setting up real application clusters, DataGuard, GoldenGate, whatever they do, and whatever we offer them, Key needs to work with it. And so that's basically why Oracle Key was born. And with OKV 18, 5 years ago, we introduced the cluster topology. So in this case, you can network up to 16 OKV nodes together to one OKV cluster. It's deployed in read-write pairs. So here in this picture, node 1 and node 2, and 3 and 4, those that are connected with this red arrow, that's a read-write pair. And those are updated synchronously. So if your database connects to OKV number 3 to set a key, then your prompt on your database will only come back after the key has been replicated to node number 4. And then over time, those keys will also be replicated asynchronously to the other OKV nodes. So after a little while, your keys will be available everywhere. We try to get as deep into the Oracle stack as possible, and you can deploy OKV on-premise, on dedicated hardware, or as a VM. And you can also deploy OKV in OCI from the cloud marketplace into your OCI tenancy. You can run OKV as a VM in Azure, AWS, and Google Cloud. So wherever your databases are, OKV is there, ready for you. And it's always the same user interface. There are no changes to the behavior. You can most certainly network cloud-based OKV instances to your on-premise OKV cluster. And that would certainly help with our customers' journey to, well, to any cloud, basically, not only to OCI. Well, as I said, we try to get as deep as possible into the Oracle ecosystem. OKV understands the wallet. That is something that is unique to OKV. Other companies, of course, don't know how to do this. It's proprietary technology. And we constantly try to make OKV more attractive for our customers by adding new use cases to it. So OKV was born as a key manager for TDE, but over time we added more things to it that make it more attractive without raising the price. So here's something new. Our customers have been waiting for this for a long time. They wanted a management interface, they wanted a monitoring interface for OKV. So now finally with Enterprise Manager 24 AI, we can do that. It's a remote monitoring, meaning we don't want a potentially compromised Enterprise Manager agent in OKV. So what the Enterprise Manager people did is they introduced remote monitoring. You have the EM agent run on some other machine, and the EM agent will connect into OKV via SSH and execute RESTful monitoring commands or SNMP commands and display that information in Enterprise Manager. So this is your first page when you connect to a cluster, and then you can drill down into your cluster nodes and see how they are doing in terms of system performance and system load and all those good things. So that is in Enterprise Manager. In OKV 21.4, we introduced non-extractable keys. So what you see here is the default behavior. When you install an OKV client on the database side that contains a PKSS11 library. That library does all the intelligent work. It finds out if the current key in the memory cache or in the persistent cache are expired. If they're not expired, then those keys will be used to encrypt and decrypt the data encryption keys. If those keys are expired, it will automatically reach out to OKV, get the key, refresh the cache, and then do its work. With non-extractable keys, all this goes away, and the library just hands over the encrypted and decrypted data encryption keys to OKV, and all the crypto work is done in OKV itself. So this is basically what we call the HSM mode of operations. The behavior is similar to what you expect from an HSM, because from an HSM, the master keys cannot leave the FIPS boundary. In OKV, the master keys cannot leave the cluster boundary. So it feels the same. It is a little different in that our keys can travel between cluster nodes, but they cannot leave the cluster boundary. If customers already have an HSM, they can put it to good use and extend the crypto chain from your encrypted database into an HSM where the wallet password inside OKV is encrypted with a key that lives in the HSM. So if OKV cannot reach the HSM, it will not start. If we lose connection to the HSM while OKV is running, it will go into the alert log. So OKV administrators know that OKV has lost the connection to the root of trust HSM, but we will continue to work. So there is no service interruption, everything is fine, but we alert the customer that you better do not restart OKV right now because we wouldn't come up again. So HSM vendors can self-certify their HSM to provide root of trust for Key Vault, but it's always important that you explain to your customers that they put OKV between the encrypted databases and between their HSM. And I will get to why that is in a moment. So use cases. I mentioned that we try to make OKV as interesting to customers as possible. So as I said, on the left side, you see those different database deployments, whatever the the database product managers come up with, we will support it because they sit right next to us. We work with engineered systems, with the recovery appliance, with ZFS, and then, of course, with all those OCI-controlled databases on-premise or in cloud or in third-party clouds. And we always try to extend our reach. So we supported MySQL for a long time. GoldenGate is also, that was one of the very early requests from one customer who triggered the development of OKV. Basically, they wanted to encrypt the GoldenGate, they wanted to provide key management for encrypted GoldenGate trail files. We provide key management for MongoDB. There are more databases coming. And so this slide will be very crowded soon. So here again, which cloud databases do we support? It's literally almost everything that's available. The reason why the checkmark for BaseDB in OCI is not green is that the certification is still pending. So this checkmark will be green very soon, and then maybe, as you can see, BaseDB is not planned for now in other database in other clouds, but that may come. So as I mentioned earlier, wherever your databases are, OKV will be there. Here is the new use case that Ethan talked about briefly. This is OKV and SSH key management. So if you don't regulate or clean up your SSH act, then it will be very chaotic. On the left side, we have a user John who likes to log in into the remote server Phoenix. In order to do this, we need to get John's public key into the remote server. So how do you do this? You either copy it yourself. That requires the knowledge of the password, which basically defeats the purpose. Or you need to annoy the administrator of the remote server and ask him, hey, can you put my public key into the authorized keys file? This looks very boring if you have only one user and one remote server, but imagine you have 500 administrators that connect to 2,000 remote servers. So then this becomes very crowded. And nobody in this enterprise will know if private keys have been shared, which nobody would do. You don't know if maybe John left the company or he is assigned to a different remote server. Theoretically, somebody has to clean out the public key from the authorized keys file, but if you have 500 administrators, this is most likely not going to happen. Then you don't know what keys those people are using. It could be RSA keys of different lengths. And do those keys satisfy your internal security policy? Maybe not. And how old are those keys? For how many years have they been used? So you know nothing. And if you add OKV into this picture, then everything becomes clear. So the way that we do this is we install a special endpoint, the SSH server endpoint on the remote machine. The SSH server endpoint can only connect to an SSH server wallet. And an SSH server wallet, it can only store public keys. Right? That is how it is designed. It will not be able to store anything else but public keys. So now we upload the public key into the SSH server wallet, and John won't even notice a difference. As long as the public key is in reach for the remote server, who has only read-only access to the server wallet, John will not notice a difference. The behavior is exactly the same. Now, if we remove the public key from the SSH server wallet, John no longer has access. So we provide remote server access controls by simply removing a public key out of that server wallet and putting it somewhere else until we can re-establish the connection. So that's one part. Most of our competitors in this area do this. They provide access controls to remote servers or private key governance. OKV does both. So this was the remote server access control part, right? If the SSH, if the public key is back in the server wallet, then John will be able to access. Now, if we extend this whole thing and implement private key governance, then in this scenario, an SSH admin in OKV would create an SSH key pair in OKV, right? We have a new page in OKV that allows you to create keys, and one of those are SSH key pairs. You would assign that key pair to be put into John's wallet, and then you copy the public key into the SSH server wallet so that the remote server has access to it. And then John can access the remote server without even having private keys on his workstation. So that's a big deal because the administrators on the left are not necessarily security savvy or security aware or security professionals. Um, they may not know how risky it is to put a private key onto their file system of their workstation. So now the SSH admin defined the private key as non-extractable. Again, the key can be shared across OKV cluster nodes, but it cannot leave the cluster boundary. And so this key can no longer be compromised, right? Only John has read-only access to that wallet that contains the private key that he's using. He is no longer in control of a private key. He is just using a private key that was created for him in the OKV server. So that is how we clean up this whole situation. And now that everything is centralized, oh yeah, this is the Windows use case that is new in OKV 21.10. I thought that this is really important because most of our customers are using Windows workstations to access remote machines. So here in the first window, we see that there are no keys in the SSH directory of that Windows machine. Right. And then on the second window, we confirm that the private key that we can see by doing OKV util list, and you see that the private key is non-extractable. And then in the lower window, we just connect to the remote machine without having keys either on the administrator's workstation, and we also don't have public keys in the authorized keys file on the remote machine. Because everything is centralized, we can monitor everything, so we know who accesses which machine, and yeah, we know all those things that you were completely clueless about before. We now bring light into the situation. So here is another use case that I talked about briefly: key management for Oracle for GoldenGate trail files. Trail files are always in clear text normally. And clear text trail files are a gold mine for an attacker. So even if the database is encrypted, the trail files would be in clear text. But GoldenGate introduced trail file encryption many years ago, but it is wallet-based. So you have a wallet that contains a key right next to the encrypted trail files. Yeah, you can do that, but from a management perspective, if you rotate the key on the extract side, you need to copy the wallet over to the replication sites and restart the replication process. It's similar to the behavior of DataGuard. And so if you put this into OKV and you put a new key into the OKV node that's on your extract side, then that key will be available immediately to the replication side. And we know that GoldenGate can extract from one source and replicate to 20 different sources at the same time. So we need those 20 sites where the data is replicated to, they need to have access to the OKV node to get the key. So this is one use case that is a very strong pull for OKV. We have customers who bought OKV only for key management for GoldenGate encrypted trail files. Secrets management. In this example, passwords. If you have regularly executed maintenance script that log into a database to do an RMAN backup, rebuild indexes, refresh materialized views, all those things that your maintenance scripts may do, those maintenance scripts need username and password to log into a database. Of course, putting username and password into the script itself is a very bad security practice. For this, the Oracle introduced the Secure External Password Store, which allows you to put one password per connect string into a wallet and then reconfigure your database so that if somebody connects to this connect string, we get username and password out of the wallet and we log in. So that's a little bit more secure than having the password in clear text in your maintenance script. But what if you rotate that password, right? You need to change it in your database and in your wallet. And wallets can be deleted, the files can be corrupted, things can happen to the wallet. And then if the wallet is not available or if it cannot be opened for whatever reason, then you don't have a backup or you didn't rebuild your indexes, right? There are consequences. And if you put this into OKV, you can set this up once. You can rotate the password daily. The password will be available in OKV for the maintenance script only when the maintenance script runs, right? We can assume that everything here is NTP controlled. So all the elements, each database, OKV, everything is on the same time. And when the script is scheduled to run at 3 in the morning, then we can program the password in OKV to be only accessible between 2:59 and 3:01. If you try to get that password to any other time, you will fail because it's not available, right? We can make that time only the time window where the password is available very narrow. And so the script can only log in, can get the password, log into the database, do its maintenance work, and then exit. Now, as I said, you can set this up once. You can automate the regularly password rotation. You can use any strength passwords that you can come up with because humans are not involved. They don't have to type in passwords. They don't have to remember passwords. That's all automated. In Oracle Database 23 AI, database account passwords can be 1024 characters long. This password here in green is 1024 characters long. I'm just showing that to you. So I would say that this is post-quantum safe because even a quantum computer would take a little time to break such a password. And I mean, writing this down is useless. You will make a mistake. Storing it somewhere, nah, we don't do that. So the best place to put such a password is definitely OKB, right? Everything else is useless. We try to make it easier for our customers to pick up the solutions that we had in mind when we designed something in OKB. So for example, we provide key management for DBMS Crypto. DBMS Crypto has the documented weakness that the developer who's using DBMS Crypto has to take care of encryption keys that are used by DBMS Crypto. So now there comes OKV, and we provide key management for DBMS Crypto. We did this with a Java SDK. And not all people are Java developers, so we made a package available that customers can download. They can make a few changes so that it fits their environment and they can start using it. So this makes it much, much easier for our customers to uptake stuff outside of TDE key management. So, sometimes I get asked, how does OKV compare to OCI Vault? Well, almost it's hard to compare them. Um, the most important aspect for our customers seems to be that they would like to keep control of their encryption keys. If you put your sensitive encrypted databases on somebody else's computer, which is called cloud now, I would have a problem if I'm a security guy in that company. I would have a problem with handing over the keys to the same cloud provider that runs my encrypted databases. That doesn't sound right. So, yes, we can move to the cloud, but we should definitely keep control of your keys. And OKV allows that, as you can easily see. And as I mentioned before, we are everywhere where your databases are. Right, OCI Vault is limited in where it can be deployed, where it can provide key management, and it's very expensive if you look into HSM-based keys. So here is how it looks when you plan to deploy OKV into your OCI tenancy from your cloud marketplace. It takes roughly 10 minutes to deploy. And here are screenshots from OKV running in other clouds. So the first one is Microsoft, then Google, and then Amazon. And the way that you deploy such an instance is you build an OKV cloning template. You can do that on-prem in VirtualBox, for example. So you install an OKV until you are 95% done, right? It will tell you at one point that the installation is completed. And then you go through the post-install steps. That's the normal installation. When you create a cloning template, you stop after those 95%. You run a script that tells OKV, hey, I'm a cloning template. I will make changes to some configuration files and then I will shut down. That cloning template shuts down. You will never start it again because if you start it again, it will start configuring itself. So that cannot happen. You would transfer the cloning template into your third-party cloud tenancy and then clone it. right? Virtual environments always have, at least all that I know, have cloning capabilities for virtual machines. So you clone it 2 times or 4 times, and then you start your clones. You go through the post-install steps so that they become unique. Each OKV node becomes unique, and then you can build your cluster. And from that moment on, you enjoy the same continuous availability. You have your horizontal and vertical scalability, and you know how OKV works because you have used it on-prem in years before. So you have a familiar user interface, you know how to operate OKV. There is no learning curve. And as I said, we are everywhere. We are in every cloud and on-premise. So now I'm coming to my favorite topic, comparing OKV with third-party key managers. I mentioned before, OKV has been built by the same group that builds the other security products in Oracle. Right? So we're sitting right next to the PMs for DataGuard, for RAG, for everything else that we do with our database. And so in the planning time of those new features, we can talk to them and we can figure out, hey, what are you doing? And we can make sure that OKV works with everything. If you have a key manager, which is different from an HSM, we will get to it in a moment. They claim that they work with DataGuard and they claim that they work with everything else, but it would be up to them to confirm that this all is true. And if you look at the videos and the integration guides that our third-party key management providers write, you already see that their handling of TDE is not up to the latest features, right? They're always a little bit behind. They misconfigure the database. They make it too complicated. And of course, if you onboard an idle single instance database into any key manager, of course it will work because there is no load. But what happens if you have an Exadata system with 200 PDBs and you turn them on? So you have 200 PDBs that reach out to an HSM and want their keys. Now you can imagine that the start of half of those PDBs will time out because they don't get to the key quick enough. And here, this resonated very well with customers when I was a sales engineer. So here you have a situation, you have wallet-based TDE, you rekey a few times, you have, say, 3 keys in your wallet. And then you decide, okay, let's go to a third-party non-Oracle key manager. So a migration is always a rekey operation, meaning we have key 4 in the third-party key managers. And then over time you rekey, you get 2, 3 more keys, but you already notice that the wallet keys are missing. Right? So if you need to restore a backup that needs key number 2, you need to keep the wallets around. And the PCI requirement is that you cannot have key encryption keys on the encrypting server. So if you don't use OKV, you will never be PCI compliant because your wallet needs to be kept around until you can guarantee that you don't need to access a backup that was created with one of those first 3 keys. And at one point, maybe your hardware gets old or you would like to retire the HSM, you reverse migrate out of the HSM. Reverse migration is also a rekey operation, so that gives us key number 7. And newer database releases allow us to merge wallets. So we can at least merge the old keys into the new wallet. But again, the keys from the HSM are missing or from the third-party key managers. So again, after reverse migrate, if you need to restore a backup that used key number 5, you need to keep the HSM around. So you can, on the first side, you never really get into an HSM because you need to keep your wallet around. You can never get out of an HSM because you need to keep the HSM around. So, and this is always a very nice story to tell your customers. Of course, this looks different when you use OKV because OKV understands the wallet. We allow you to upload the wallet into OKV. Then we migrate. That gives us key number 4, and we can delete the wallet because we have them uploaded into OKV. So that satisfies a PCI requirement that encryption keys cannot be kept on the encrypting server. So now we rekey a few times. We have an uninterrupted chain of keys. If Arman comes along and needs to restore a backup that needs key number 3, the database will redirect Arman's request to OKV and get key number 3. This is all done transparently without the customer having to do anything. And then, which will never happen, people reverse migrate out of OKV. You would download the wallet and then reverse migrate. That gives you key number 7. Again, we have an uninterrupted chain of keys. You can indeed decommission your OKV cluster. That's a clean solution, not some fancy workaround. So here's another problem. HSM, as I said earlier, the FIPS validated module is maybe a PCI card with memory, CPU, and a disk. And that's fixed. It's a fixed number of CPU, a fixed amount of RAM, disk speed, storage, and the load towards a key manager will only increase over time. So at one point, you will hit that maximum load that this little PCI card can handle, and your encrypted databases will abort operations. And with OKV, because we provide, it's a soft appliance that can be installed on any size server, we scale vertically, which means you make your cluster nodes bigger, or we scale horizontally. You add more nodes to your OKV cluster. You can put in SSDs instead of spinning disks. You can increase the number of OKV nodes. You can play with your key caching settings. And so OKV grows with the load. There is no day X when this thing falls apart. How do you learn Key Vault? So there are two LiveLabs. The first one is you learn how to migrate an encrypted database to OKV. And the other one is the one that Ethan mentioned before. This is where you can go through the SSH use case. So here are the the QR codes. And yeah, so what's new in OKV 21.10? We talked about this already. We have additional platform support, so the OKV can be installed on the Linux and ARM CPUs. My favorite backup solution for OKV is definitely ZFS, because ZFS provides immutable backup snapshots and retention periods. And OKV 21.4 introduced a matching policy-based backup deletion. So you can set the retention period of your OKV backups to, I don't know, a month. And then a day later, OKV comes along and deletes the old backup. So you don't run out of space in your backup storage. Customer stories, you heard about them. The energy trading company is interesting because they have XRDB clouded customer, but they didn't want to invest into the hardware cost for an OKV cluster. So they provide key management for XRDB clouded customer by a 4-node cluster that runs in OCI. And then, of course, we have a big bank in Germany who bought over 100 database clouded customer, XRDB clouded customer. And we tried it, and under our eyes, we could see that the HSM couldn't handle the load of 1, and they have 100. So they also have a large-scale deployment of ODA machines. They will also go into OKV. Okay, so here again, the best place for your encryption keys is Oracle Key Vault, continuously available, scalable, fault-tolerant, purpose-built for the Oracle database, and we have a persistent cache.